we are going to have this to be y prime to be equals to a e to power x plus, if I open this bracket, we are going to have this into this will give us plus bx e to power x. Then this into this will give us plus b e to power x. Then this minus will affect this plus to be negative. This negative will affect this plus to be negative. So I'm going to have this to be minus c e to power minus x. Let's call this equation 2. Okay? Okay, let's clean the board. Next, remember we have up to 3 constants. We're going to differentiate 3 times. We found the first derivative. Next is to find the second derivative. Now we're going to differentiate this y prime with respect to x again. If we differentiate this y prime with respect to x again, this is going to give us y prime prime, which is equals to, now differentiate this, a is a constant, differentiate e to power x, it will still give us the same, e to power x, it doesn't change. This plus is this. Then we have b is a constant. The derivative has to be on x e to power x. We have done that. If you differentiate x e to power x, we're going to have x e to power x plus e to power x. We've done that. Okay. We now have this plus is this. Then differentiate. Of course, b is a constant. Look at it. Differentiate e to power x, it will still give you the same thing, which is e to power x. Then we have minus. C is a constant. Differentiate e to power minus x. Of course, you know it's going to give us minus e to power minus x. That's what it's going to give us. Let's simplify further. So that will give us y prime prime, which is equals to a e to power x plus, if we open the brackets, we are going to have this to be b x e to power x. Then this into this will give us plus b e to power x. Then plus b e to power x. This minus will make this minus to be positive. So we have c e to power minus x. Okay. Okay. So if we go further, you find out that this is going to give us y prime prime. Y prime prime will be equals to a e to power. Any other a e to power? No. So e to power x, then plus bx e to power x. Any other term? No. Bring it down. B x e to power x. Now look at this. Plus b e to power x plus b e to power x automatically will give us 2b e to power x. Then finally plus c e to power minus x. Let's call this equation 3. Equation 3. Okay. There is need for us to find the third derivative. Remember, we have 3 constants. Because of that, we are going to differentiate the function into up to 3 times. So we have done the first one. This is the second derivative. We are going to find the third derivative by differentiating y prime prime. Okay, so if we do that, that becomes y prime 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 will now be equals to differentiate a e to the power x. It will still give us the same thing, a e to the power x. We've done that. Then plus b differentiate x e to the power x. We've done that before, so this will give us x e to the power x plus e to the power x. You close the bracket. Then we have plus 2b is they are said to be constant. 2b is a constant. Then differentiate e to the power x. It will still give us the same thing, e to the power x. Then plus c is a constant. Differentiate e to the power minus x will give us minus e to the power minus x. If we further simplify, we are going to have that y prime 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 will be equals to a e to the power x. Then this b will multiply the two terms inside the bracket. If that happens, we have that plus b into this will give us b x e to the power x. Then into this will give us plus b e to the power x. Then followed by plus 2b e to the power x. This minus will make this plus to be minus. So we're going to have this to be minus c e to the power minus x. Therefore, we now have that y prime 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 now becomes a e to the power x plus b x e to the power x. Then b e to the power x plus 2b e to the power x will give us plus 3b e to the power x. Then finally, we now have minus c e to the power minus x. Let's call this equation 4.